Remember our example on equilibrium attained on an escalator? You are going up on an escalator which is coming down at same speed. Thus, you appear to be a fixed point on the escalator. Suppose your mischievous friends decide to increase the speed of the escalator. In order for you to still remain at the same point, you will have to increase your speed to match the speed of escalator. Equilibrium. If stress is placed on a system at equilibrium, the system will proceed in the direction that maximizes the stress and helps in restoring equilibrium. Stress can be applied on a chemical reaction by changing concentration, temperature, or pressure. Concentration can be changed by adding reactants or products to a reaction. If you add reactants, the system will start creating more products to reduce concentration of reaction and restore equilibrium. If you add products, the backward reaction will start occurring at faster rate to reduce concentration of products and restore equilibrium. Two different colored cobalt complex ions, COH2O6 and COC4 exist together in equilibrium in an aqueous solution in the presence of chloride ions. This equilibrium can be distributed by changing the chloride ion concentration or changing temperature. If you increase concentration of chloride ions by adding more HCl, more products will be formed and solution will turn blue. If you add more water, reaction moves backwards and solution turns pink. For example, in the process of creation of ammonia gas, one molecule of nitrogen gas combines with 3 molecules of hydrogen gas to form 2 molecules of ammonia. Here, number of molecules of reactants are 4, while number of product molecules are 2. Thus, if you apply pressure, system will create more ammonia, reducing the number of molecules. And if you release pressure, backward reaction will be favored. Equilibrium on basis of the direction of endothermic and exothermic reactions. If temperature is increased, system will move in the direction which absorbs heat, thus favoring endothermic reaction. If temperature is decreased, system will move in the direction which releases heat, thus favoring exothermic reaction. In our above example of cobalt-2 ions, forward reaction is endothermic and backward reaction is exothermic. If you increase temperature, forward reaction occurs more rapidly to absorb the heat and solution turns blue. However, if you decrease temperature, reaction moves backwards, turning the solution pink.
before with nitrogen dioxide. In addition to that, 2 beakers were prepared with ice water and hot water. In the hot water, the gas becomes more darker, while the color becomes more pale in the ice water. This happens because the brown nitrogen dioxide exists in an equilibrium with its colorless dimer dinitrogen tetroxide. At high temperatures, the equilibrium shifts to the left, at a lower temperature to the right. This can be explained with Le Chatelier's principle. When a system at equilibrium is subjected to a change, it changes to a new equilibrium to minimize the effect of the change. In this case, the effect is achieved by changing the temperature. The enthalpy of reaction of the forward reaction is negative, which means that it's exothermic. When the gas is cooled, the equilibrium shifts to the right, while energy is released to act against the cooling. The enthalpy of the reverse reaction is positive, so it's endothermic. This causes the equilibrium to shift to the left in the hot water to act against the increasing temperature.